We will now discuss projectile motion. Suppose a projectile is fired from the position r0 at an angle of elevation alpha with initial velocity v0. Find parametric equations for the motion of that projectile. So what we have is we have an object. That object is located at r0. We'll call that x0, y0. And then we're going to fire that projectile by giving it an initial velocity. So we will give this an initial velocity. We'll call that initial velocity v0. And the initial velocity has an angle of elevation, so an angle from the horizontal, that we call alpha. And then we want to find what is the path of this projectile. So we want to understand what is the parametric equations for the path of this projectile. Well, we're going to use what we know about position, velocity, and acceleration to solve this problem. So we're going to start with an initial position. We'll call that r0, which is x0, y0. And then we want to look at the velocity. We'll call that v0. And we're going to decompose the velocity into horizontal and vertical components in the ways that we've done it before. So this would be the magnitude v0 times cosine of the angle alpha for the horizontal component, and then v0 sine alpha for the vertical component. And then finally, we have acceleration. The only acceleration for this projectile motion is the acceleration due to gravity. So there is no acceleration in the horizontal direction, but in the vertical direction, we have the acceleration minus g, where g is the gravitational constant. So that's 9.8 meters per second squared. So the only force that's acting on this object is going to be gravity. So that means that it's feeling an acceleration only in the vertical direction. That's going to be minus g. So how is it that we can then find the position? Well, if we know acceleration, then we know that the velocity is just the integral. So velocity is in fact going to be the initial velocity v0 plus the integral from 0 to t of the acceleration vector 0 minus g ds. We know this because of the second fundamental theorem of calculus. If you take the derivative of velocity, you get acceleration. And if you take the derivative of this constant, you get 0. And then if you take the derivative of this integral, then you just get what's on the inside. That's the acceleration vector 0 minus g. Of course, v of 0 in this case is going to be v sub 0, because if you plug in 0, say here, then that integral is going to be 0. So v of 0 is v sub 0. Okay, so let's actually do that integration. So this is going to be v0 plus, what is v0? Excuse me. v0 is v0 cosine alpha, v0 sine alpha, and then plus, and we're going to get 0, and then, because when we integrate 0 there, we get 0 from 0 to t, and then minus gt. So we can combine those if we choose. That's going to be v0 cosine alpha, and then v0 sine alpha minus gt. Now, what is going to be the position? Well, again, the position we can get just by integrating the velocity. So position is going to be the initial position, r0, plus the integral from 0 to t of my velocity. My velocity, of course, is v0 cosine alpha, v0 sine alpha minus gs ds. So here we have r0, which is x0, y0. And now I need to integrate the velocity. That's going to give me v0 cosine alpha is just a constant. So that's v0 cosine alpha t. And then v0 sine alpha is just a constant. So that's v0 sine alpha t. And then when I integrate minus gs from 0 to t, I'm going to get 1/2 gt squared. So r0 or r of t, our parametric equation for the position is going to be x0 plus v0 cosine of alpha t cosine of alpha times t, excuse me, and then v0 y0 plus v0 sine alpha times t minus 1/2 gt squared. And this is the parametric equation for the motion of the projectile. So you can see why I drew that projectile as a parabola, or as close to a parabola as I can draw, because you can see that the vertical motion there in time is going to be a parabola. So these are essentially what are known as the kinematic equations in physics. There are other kinematic equations as well that maybe they make you memorize in physics, but you don't have to. All you have to do is start with acceleration and then integrate twice, and that will give you the position of this particle.